So this is going to be our second example of a multi-file program. And we're going to start out with multifile2_original.c. That's the file we're going to convert to a multi-file format. So let's walk through what's going on there. So at the top of the file, we're including standard.io.h, and we have some symbolic constants, one for multiple, one for size. Some inline functions. So here we're defining triple to be a times 3. And again, anytime we have an inline function, we always want to surround each parameter with parentheses, because if we don't do that, we can have trouble with once the replacement is done. Because remember, it replaces whatever is passed in whatever the macro is equal to. So here, by putting parentheses around it, we just get a little bit more safety. So we have some forward declarations of some files or some functions that we're going to define below. Here we have a global variable called counter. We're going to use that to keep track of how many times we call a function in this particular file. And then here's our main method where we go through, we initialize the counter, and then we start calling functions, including factorial. So here we have some counter functions. And then here we have just some general functions. And of course, these are all pretty much just toy functions. They sort of form as a review of all the stuff we've talked about functions. Here we have something that takes a integer parameter by value. So we get a copy in this local parameter n for our function. And then we return n plus 1. If we modify it in here, since it's a call by value, we wouldn't affect the caller. Here we have a doublet function, and that takes a parameter, but notice this is a pointer, and then we actually dereference the pointer in the function, so this will actually change the parameter or the variable that this is pointing to. And then finally we have factorial, which is a recursive function. If you pass a value less than or equal to 1, it returns 1, otherwise it returns n times factorial of n minus 1. So this is our original file. This is the one that we're going to break up into multiple files. Just to show you how that works, let's compile this and run it. And when we run, you can see here's the counter. We're adding 1 to a to get 11. When we add 1 to 20, we get 21. And then we call, let's go back to our function. Then we're calling doublet with a, so that gives us a, that changes a to 20. Here's 10 factorial, and finally, once we're done, we print the counter. Notice the counter jumps up a lot when we call 10 factorial. Factorial gets called 10 times, and so we add 10 to counter while that's executing. Notice for add 1, we're able to pass a variable or a integer primitive, but for doublet, we need to pass the address of some variable since it's expecting a pointer. And just to show you how the preprocessor works, if we do -e to just run the preprocessor, we get a bunch of stuff. Most of that is including standard io.h. But if we scroll up, you'll notice that we're actually not using the preprocessor at all. So maybe we want to add some of those. So we have 3: triple, absolute value, and max. So triple, again, just takes a parameter, multiplies it by 3. Absolute value, and actually let's just go ahead and call it, well, we'll leave it at that. So it takes a value, compares that value to a. If it's less than a, it takes the opposite of a, and then otherwise it takes, or it returns a, since in that case it would be positive. And then max AB takes 2 values, A and B. It compares them. If A is greater than B, it returns A. Otherwise, it returns B. Also, to be consistent, let's make these all uppercase just to indicate that they're not regularly defined functions. So we'll do triple A And then we'll do something similar for each of these. We'll do absolute value of A. And I forgot to make all of these capital, or all uppercase. And that needs to be a parentheses. And then let's try max. We'll do -10 and 5. And then to make sure that this works, let's do 1 and 5. Or no, let's not do 1. Let's just do, we'll do 11 and 5. And that way we make sure that no matter which parameter is larger, it returns the correct one. So let's see if that works. And let's take off the E. And so other than a misspelling here, which is easily fixed, it looks like all of those give us the correct value. So let's fix that. So now, this is an introduction to what this file does. Now, let's break it into 3 separate files. So I'm going to copy multi-file original to and I'll create a subdirectory here. I'm going to copy it to multi-file or actually let me just call this my functions. My functions.h. I'll also copy it to my functions.c. So now let's take a look at those, or let's edit those files. So for the header file, again, the first thing whenever we do a header file is we want to make sure that we include the guards. So if my functions _h is not defined, then we're going to define my functions.h, and then we want to make sure we remember to do an indef at the end. We don't want to include an unnecessarily include statement in our header file, so we're going to delete that. We're going to keep the symbolic constants, we're going to keep the inline functions, and we're going to keep the for declarations. We're not going to keep int counter. We're going to think of int counter as, even though it's a global variable in our original file, it's going to be a private global variable inside the myfunctions.c module. And of course, we don't want any of this code in our header file. So we're going to get rid of all these functions, and that completes our header file. So now, let me edit my functions.c. So now, I don't need to include these symbolic constants, or the inline functions, or the forward declarations. Instead, I can include my functions.h. And you'll notice there that we used quotes, not brackets. I also still have a main method here, and I'm going to actually move this to the bottom. So let me see how many lines this is. So I'm going to move main to the bottom. And I don't always necessarily want this main to run, because I want to create this myfunctions module that I can include in other files. So what I'm going to do is I'm going to surround this with an if-def test. And again, whenever you have an if-def, you want to include an indif. So now when I compile my functions.c, I get a bunch of errors. So for some reason it's compiling this twice. Oh my. So this might go down as the dumbest error I've ever made. Notice I'm including my functions.c twice on the compile line. So the reason that it was being compiled twice is because I was including it twice in the compile statement. So here we're getting a problem, undefined reference to WinMain. So this is happening because I'm running this on a PC. You would get a slightly different error if you were running it on Linux or Mac, but ultimately it's an undefined reference to a main value, or main function. And the reason is if you remember in our myfunctions.c, we have this if-def test surrounding main. So if I want to include the main method here, I need to define test at the command line. Now notice I got a good execution. And if I run this, you'll notice everything looks good. Other than I need a new line here. Okay, so let's write a example of a file that's just going to use the include file. And this will let us see how the preprocessor works. And I'm going to define another number here. And if you'll remember in myfunctions.h, we defined multiple in size, but we didn't define num. So I'm going to define num here to be 10. So here's my main function. And I'm going to set some integers here. So here's x, that's going to be num. We'll say y is equal to 0, and z will be equal to 0. We'll do a while loop for while y is less than num times 2. We will set z equal to max of x and 12. And then we'll increment y. So we'll add printf in a moment, but first, let's see what happens if we compile this file using the preprocessor flag. So you'll notice, first off, you don't see define num anywhere, but everywhere we use num in the code, for example here and here, it's been replaced by a 10. Whenever you see that defined, the preprocessor replaces any instance of this outside of a string with 10. In fact, just to demonstrate that, let's create an array, and we'll set that equal to the string num. And notice that num is left alone because it's in a string literal. Another thing you'll notice is that max, x, and 12 hasn't been replaced because we forgot to make it all caps. So now let's run this again, and you'll notice now max has been replaced by that macro we defined in my functions. So you don't see those defines anywhere in the output here, but notice you do see the forward declarations that appear in myfunctions.h. Now if we include printf, or I'm sorry, standard io.h to do a printf, And the first thing you're going to notice is when we do the compilation with the -e flag, we get a bunch of extra stuff. And that's all of the details from standard.io.h being copied into our C file before it's passed to the compiler. So now let's take the E flag off. And we actually might run into errors before, because when we do -e, we're not actually compiling it. We're just running the preprocessor. Without the -e flag, it runs the preprocessor. That preprocessed file then gets passed to the compiler, and now we have an executable that we can run. And you can see here's all of our values. I think it'll be more interesting if we make this the max of y in 12, so that it changes every once in a while. So for some reason we're not... yeah, so you'll notice z is 12 up until y becomes 13, and then we update z each time because the value of y is greater than 12. So just to make that a little more clear, I think if we make that 10, it'll be a little more clear. And it's also important to keep in mind, if we go back to, or if we want to take a look at one of those functions that we have defined, and I don't actually even need to know what this file is, I just know that I have access to it. So I can do add one here. So what's one of these that would be a good, let's add one to X. And when we run this, it doesn't know what add one is because we need to compile with myfunctions.c. And once we do that, notice we were able to add one to 11. Now, one thing I noticed is I didn't include a init counter in my, or not a get counter in my forward declaration. So if I go back to preprocessor, that we would think that would work, but we get implicit declaration of get counter. And when we run this, it does actually work, but that's only because the implicit declaration matched what this was. So if we change that somehow, then we would have a bug. And what we want to make sure is that we declare it if we want to provide it to outside functions. So we'll copy and make a forward declaration there. And now, when we go back to preprocessor.h, first off, if we do the -e flag, you'll see that now we have the get counter method there. And then we compile it as normal, and we can run it.